I don't know. I can't tell. I can't.
All right, we seem to be back in action.
Hello. It's not responding.
Yeah, it is.
It's a little tiny. Hi, RSD.
Is it working or not?
Air high five. Yeah.
Okay, so everything on here, all the examples I just gave, as a BA or Dylan or somebody said, they're all on the line. Okay? So what that tells us is when we use a graph as it is drawn, please capitalize that, highlight it, do whatever you need to do. The graph as it is drawn to get data, or data, depending on how you say it. If we use the graph that is already drawn to get data, it's called interpolation. Interpolation. And all that means is the info is already on the line. So we were able to do X and Y, X and Y. Don't even bring it to my class tomorrow. If I even see it in your hand when you walk in the door, I'm taking it away.
I'm going to have my pocket.
Nope. Well, you can be in your pocket, but if I see it, I'm taking it away.
What did you see it through my pocket?
If I see it, I'm taking it away.
Got it.
So, if the line is there and your information is already on the line, that is interpolation. Remember, the graph tells you two different things. The information you are given exists on one of the axes. The information that you want exists on the other axis. Okay? So go. Figure this one out. What is the information that I have? So what do I have? Do I have the liters or the cost for 1A? I have the liters. So where do I go? The X or the Y axis? The X. And I go to 15. Do I know how much the cost is yet? Not until I go up to the line. And then, does that give me a cost? Yes, when I go across and I see where it is on the scale. How much is it?
14.
Probably around $13. Because this would be 15. I would say 13 to 14 bucks. Got it? Interpolation, because the point we cared about was on the graph. What about this one? $10. So which axis do I start on? The X or the Y? The Y axis, the 10. I go out to the line, and I slide down, and it is slightly more than 10, yes? So 10 to 11. Got it? Please notice that these are estimates, because this graph is not very exact, is it? It goes up by 5s. Cool? Okay. Now you guys are smart kids. On the family trip in Calgary Moose Jaw, Bobby wants to predict how long it will take to go 640 kilometers. How far does this graph allow us to go? Only 400. So is our information going off the graph? Yes, it is. So we cannot use interpolation. We are using this graph to estimate a situation further in the future. How do we do that? Well, is this a linear relation? Yes. When I go 1 this way, how far up do I go?
2.
80. 180. Right? And that's going to go on and on and on, isn't it? Right? Now, we already know that 80 km will, not kh, you idiot, km is 1 hour, yes? And we already know that 320 km is 4 hours, don't we? And if they're on the same line, then what do we know about these two fractions? They're on the same line. These are coordinates from that line, aren't they? These are coordinates from that line, aren't they? So if they're on the same line, what do I know about those coordinates? They must be what? Ah, I see. Somebody has already talked about this earlier this year, so I'm going to have to take a moment here. It is 8 hours, indeed. But why? I don't need 80. I don't need 320. What do I need? 640. What happened here to get to 320? What happened here? What do I do to get from 320 to 640? Times 2. So what do I do here? Times 2 to get 8. Why are we able to do that here? What property of this relationship allows us to continue this? Dylan has already said it. He was joking about it, but he was right. It's linear. And it's weird because they're driving, right? And they're able to keep this up perfectly. So I guess they have bowls in the car to pee in. Some sort of truck drives up beside them like the planes in midair, and they grab a hose and they refuel because they never stopped.
That'd be fun to see.
Right?
They
Right?
just have a really big gas tank.
Yes, or they are towing a tanker that is hooked up to their engine. Yes.
Well, they could have a hole in the ground in the car and then they're just pouring gas.
Yeah. But essentially that's what we're talking about, yes? Because this is linear, we are able to do this. Because it is always going to change the same, isn't it? Now here we're going to drop into something from grade 10. You guys have already made mention of it. If up and down measures kilometers, and the horizontal measures hours, aren't those the components of a speed? And how do we write speed? No. How do we write if I'm going 80 kilometers an hour? What do I put right here? A slash.
Oh, yeah.
What math is that slash?
What math?
What math is that?
Division.
It's division. So what I really have here are kilometers divided by hours, don't I?
Oh, 6.
80 divided by 1 gets me 80 kilometers per hour. This is a slope. Okay? Slope gives us what we call the rate of change. Now, when it's distance and time, that rate of change is a speed. Okay? If it's not distance and time, it's going to give you a different piece of information, but it's always the rate of change. For example, if I drink 3 cans of pop in a week, what's my rate of change? 3 over 1. 3 cans per week. Got it? What if I drink 7 cans a week? 7 over 1. So it's 7 cans a week, right? What if I drink 8 cans in 2 weeks? What's my speed of drinking pop? 8 over 2, which is 4 cans a week. Picking up what I'm putting down? Everybody got it? That's what slope is. That's all it is. Many of you have talked about slope already. Now, the question becomes, did I know this from the graph? No. When we go beyond the data on the graph, we are doing what is called I better use proper English. We are utilizing or using extrapolation. Extrapolation, this means we need data from beyond the graph. I need extra data, okay? Now, which of these is more exact? Interpolation or extrapolation? Interpolation, because I have all that information. What might happen at 480 kilometers and 6 hours? No, in reality, what could happen after I've driven 480K in 6 hours? What might happen?
Run out of gas.
Yeah, I might run out of gas. Would time carry on? Yeah. Would my speed carry on? What if I stop at a gas station or the restaurant? We've been driving for 6 hours. Is my family going to want some pancakes? Maybe. Is time going to carry on? Will my distance carry on? No. So once I get to the end of this, I don't actually know anymore, do I? So extrapolation becomes a real guess. All right? Everybody with me? Now we can predict with some reasonable assumption that we are going to continue at the same speed, aren't we? Right? But there's going to be a pause for gas or food or pee. Cool? Okay. All right. Remind me never to ride behind your car.
That'd be so fun.
No, he just says he's going to pee out the window. Of course, what would be even funnier is when you hung it out the window if you had power windows and your dad rolled it up. That'd be hilarious. Yeah. That would be super funny. Yeah, everybody's done it too. I do it to my wife's hair all the time. We'll be driving along with the windows open and her hair will be out the window because it's long and I'll, damn, why are the windows open? Let's put on the air conditioning.
My grandma had a broken, so when it goes up, it wouldn't come back down. You'd have to somehow push it down. Yeah. Well, she stuffed my 3 fingers in it and it wouldn't come out.
Instead of putting you on a kid leash, she just trapped your finger on it.
Yeah. She's just oh, what? Sorry. And then you get it out.
All right, you good, Arsh? Okay, turn the page over. Use this graph to find the cost of 30 liters of fuel. Where does our information end?
30 liters.
No.
40 liters.
No.
The cost? 35 liters.
No.
At 30.
No.
Oh, it ends at 20 liters.
It ends at 20. Is it a linear relation, though? I went this way, 10, and I went up, no, just a little below 10, yeah?
9.
Right? Then I went this way, 10, and I went up, looks like about 9 again, yeah? So can I make that assumption? Out 10, up 9. And I can continue the line. Now, did I have to go beyond the graph? Yes, so this is extrapolation. I need to know the cost of 30 liters. So where do I go? On the cost or on the liters?
Cost. Liters.
Liters, because I know I need 30. I go up to 30, then across, and what do I find?
25.
It's more than 25. It's probably about 27 liters. Got it? It's pretty darn simple, isn't it? So, now, let's apply the real life situation to math, because of course math models real life.
Not all of it.
Huh?
Not all of it.
Yeah, it does. That's the whole point of math. Math is designed to model real life. That's why we have math. So we can, instead of building a pyramid by accident, you plan it out.
Yeah, this stuff is
Probability
useful, but not.
Wait, so you go inside the pyramid?
We've only had this conversation that lasted 20 minutes. No, useful.
Yeah, but polynomials isn't useful in life. You're never gonna be able to like
Math.
subtract 2x or minus 3.
Probability and social studies isn't
So-
useful.
Oh my god.
What is the value of x when y equals 3? So which axis do I start on?
X,
No, why?
Y.
You have your number.
I know the 3. I do not know the x. So I go up to 3, and I go out here, and what do I find?
No.
No line. So is this inter or extrapolation? This is extrapolation, which means what do I have to do to my graph? I gotta extend it. Is it linear?
Yes.
Over 1, up 1, over 1, up 1? Sure it is. So there I have extended my graph. So now can I find my x value? What is it? 5. Cool in the gang? Now, when x equals 1, where do I go?
What?
On which axis? The x-axis, because you know it's x equals 1. So I go to here, and now I look for the line. It's down here. Does it hit the line?
Yeah.
So is it inter or extra? Inter. And now I got to go and find my y value. Where is it? -1. Can everybody do it? It's not hard. Check this one. Go ahead, you try it. Apparently there's some neutering going on over there.
What are you neutering?
Whoa, no. That's not allowed here.
Dude,
You're
dirt.
in school.
You on your what?
All right. What do I know for 2a?
Y equals 4.
What do I know y equals 4. So I go up to 4 and I look for the line. There ain't no line. So what do I got to do? Extend it. Is it inter or extra? Extrapolation. And I'm going to carry that line on. Over 1, up 1. Over 1, up 1. Oh, there we go. So now I can go down here and what do I find? 3. Let's do the next one. X equals -4. So where do I go? On which axis? -4 on the x-axis. Now I look for the line. Is it up here? No! Is it down here? No! So what do? I extrapolate. Down one, over one, down one. Oh, there it is. And it is what?
-3. Oh, negative 3.
-3. And it is also extrapolation. Got it? Great. Now, apply it to a real life situation.
Yes.
Because this is the type of thing that we do use math for. How long can I drill at this drilling well based on this data?
Very deep. Very low.
6 days. 2 days.
How much do I drill in a day?
Let me see.
No, yeah, 500.
500? How did you know that?
I looked at the graph.
Because you went to one day, went up, and found it to be 500. How long will it take to drill 750 meters?
Well,
I go to 750 meters, there and down. Okay, 1.5.
Are you eating
Now, 3 days, is that on the graph?
see something.
Is 3 days on the graph? No siree, Bob. So what do I got to do? Extend. I go over 1, up 2, over 1, up 2. There it is. So what is it? 1,500. 2,000 meters, is that on the graph?
Yes.
Yes.
No, no.
No, it's not. Over 1, up 2. Oh, now it is.
Oh, look at that.
So how long?
Full days.
Full day.
Full day. Full.
Got it?
Full.
I don't have it.
That's it.
A
Great.
long time.
That's all she
4 days. Is that straight day and night digging?
12:32.
Well, a day is 24 hours.
Finish the day off with
Good note.
One, what's nine?
this one I can highlight because I want you to do all of 1, 2, 3, 4. I want you to do 6.
Here, do I do a figure? I don't know.
13.
I want you to do 8 and 10. And I want you to do 13 and 15. Tomorrow when you get in here, I will put a warm-up on the board. You will write a quiz right after it. Then you will have the rest of the first period to work on your review for this unit.
And then chapter 6.
That review will be marked tomorrow by the end of class, so you have it to study from over the weekend. All right? So tomorrow, when I give you work time, if you haven't finished your Unit 5 review, that's what you work on instead of textbook work.
Okay.
Okay?
Sounds like a plan, Stan. You gotta listen to music.
Of course, I'm done talking.